So let's go on to example 4. First and foremost, before I even do a substitution, the first thing I can see is that I have a tangent t plus cotangent t. I need to square it. Now remember, that's not just tangent squared plus cotangent squared. What we've got to do to make sure we square it properly is that we've got to take that denominator and we've got to write it out twice and then FOIL it. Okay? So tangent times tangent is a tangent squared, t. The outsides, I'm going to go and write it just this one time so y'all can see, and before I jump ahead, and y'all are kind of going, what did she just do? And it helps if I write cotangent and not tangent. Okay, so this is the first times the first. This is the outside, the insides, and then the lasts. Okay, well here's the thing. We have our tangent squared t right here. What's tangent times cotangent? Well, they're reciprocals because tangent is sine over cosine, cotangent's cosine over sine, so we just get 1 right there. Same thing right here on this term. Cosine over sine times sine over cosine, you get 1 again. And then we have our cotangent squared t. Okay. Well, before I go any further, let me look real quick to what we're trying to work towards. We're trying to work towards a cosecant squared and a secant squared. Well, if you know your identities, or if you have that, if you happen to write them down and keep on a sheet of paper really close to you, you will see that tangent squared plus 1 is secant squared t. Cotangent squared plus 1, or 1 plus cotangent squared, is cosecant squared t. And I'm done right there. There's my answer. So the whole thing with this problem really was realizing this part right here was that any function times its reciprocal will always give you 1. Okay. So example 5. With this example, and by the way, if you ever, I totally suggest going through this lesson, watching it again, or if you see me do an example and you kind of get lost on what would happen, just go back and rewind and watch these again. I'm trying to do kind of one of everything per se, but definitely go back and watch these as much as you possibly can. Alright, with this one, first thing I notice is we've got 2 fractions here, and our goal is to make one big fraction. So the only way I can go from 2 fractions to 1 fraction is to make sure I blend these together. I need to add these really to these 2 fractions together. And the only way that can happen, common denominators. Well, the denominators in this case are since they're both different, the way to get the common denominator is like if you had 5 and 7, 35. Just multiply them together, okay? So I'm going to set up 2 brand new fractions, each with our common denominator down below. And then again, that common denominator, when they're very different like what they are, we just multiply them together. Okay? So this numerator, the denominator is 1 plus sine x. It's missing the 1 minus cosecant x. So I take what's in existence right now, the sine x, I'm going to multiply by what it needs. Okay? Going over to the right side, starting out with cosecant. This denominator has 1 minus cosecant. It needs 1 plus sine x to get everything in there. And just to check to make sure I did this all correct, if I were going to cancel, you would take the 2 over here, those 2 parentheses right there away, and it would take you right back to your original problem. And I would normally take those 2 away and then go back to your original problem, but I don't want to do that. Okay, I want to actually leave them in there. So even though I canceled them out, I really didn't. Let's go ahead and distribute across the top. You'll get sine x minus sine x times cosecant x. And then down here in the bottom, let's go ahead and FOIL this out. So 1 times 1 is 1. The outsides will be a minus cosecant x. Insides is a positive sine x. And the last term would be a minus sine x times cosecant x. Okay, distributing over here on the right, cosecant x plus cosecant x times sine x over, FOILing out the bottom again, so 1 minus cosecant x plus sine x minus sine x times cosecant x. Alright, so let's finish cleaning this up. Well, what do we know sine x and cosecant x? It's sine times 1 over sine, so that just leaves me a 1. 1 over sine times sine cancels off, that leaves me a 1. So going across the top here, I have sine x minus 1 plus cosecant x plus 1. And then since these denominators are both the same, all I have to do is write it once. So 1 minus cosecant x plus sine x, and then sine x times cosecant x is a minus 1. Okay, so far. So let me kind of take this around. We're going to finish this up here. Let's go to our numerator. A sine x minus 1, cosecant x plus 1, the minus 1 and plus 1 cancel off, and we get sine x plus cosecant x. And in the denominator, a positive 1 and a minus 1 go away. And right now, if I write it as is, it's negative cosecant x plus sine x. If we go to our answer, just swap the two denominator terms really around, and we actually have our answer. So we can call that problem done. I guess, again, in this one, it's just realizing to get a common denominator, and when you have very unique things like this, really the common denominator is just multiplying the two together. That's all that it is. Okay, so example 6. Tangent of y over 2 sine y minus 3 tangent y. And nothing's squared, so I'm not going to use any of my sine squares or tangent squared identities. Go back to my original ones. Over here on the right, I have 1 over 2 cosine y minus 3. Okay, so this is one of those where, this is going to be an example where if you need to watch it once and then come back to it, this is a really good one. So I'm going to say a lot of things that you might want to watch twice in order to pick up on. But again, starting out, I have one fraction here on the left. I'm working to one fraction. Okay, up here in the numerator, I have one term. In the numerator on the right, I have one term. The denominator on the left, I have two terms. The denominator on the right, I have two terms. So can y'all see how everything matches up perfectly? One fraction to one fraction, one term to one, two terms to two. When that happens, all you're really going to be doing is multiplying the top and the bottom of this left fraction by just one thing. What you need to decide is what is that one thing we're going to be multiplying the top and the bottom of this fraction by, because it's really going to be done all in one step and you're going to get your answer. Okay? And this is the best way that I do it, or how to decide what that one thing is I'm going to multiply by, is I pick one of the three terms over here on the left. Let's just go to the numerator. Let's say tangent. What would you need to multiply tangent by to get 1? Well, the only thing I can multiply something by to get 1 would be its reciprocal. And the reciprocal of tangent is cotangent. So I'm going to choose to multiply the top and the bottom by cotangent. I know the tops are going to work out. All we have to do is check the bottoms and we should get our answer. So let's see this. Okay, so I'm going to just kind of write it out first of all. So tangent y times cotangent y is what's on the top. And down here on the bottom, it's 2 sine y times cotangent y minus 3 tangent y times cotangent y. So just distributing the cotangent to the top and then to the both terms in the denominator. Okay, well, tangent times cotangent, that'll go away, give me a 1. Also goes away and gives me a 1 right there. So we just need to check that, really, that bottom left. So right now I have 1 over 2 sine of y times cotangent of y minus 3 times 1, which is 3. So going to where my answer is, technically right now, I have 2 of the 3 terms done. I've got a 1 in the top, I've got a 3 down there on the bottom right. All I have to see is, can my 2 sine y cotangent y be the same thing as 2 cosine y? And the way to check for that is we're going to write it as 2. I'm going to write sine y. Instead of cotangent, I want to write it as, instead of cotangent, we're going to write it as cosine of y over sine y. And look right here. The sine y out front is going to cancel with that sine y down there in the bottom. So I just get 1 over 2, cosine y. I canceled off that sine y, didn't I? And I want to leave it there. But sine y's go away, so 2 cosine y minus 3. And there's my answer. Okay, so going again back to the problem, when you realize you have one fraction going to one fraction and all the terms match up 1 to 1 and 2 to 2, all you're going to be doing is multiplying by a fraction where you're multiplying the top and the bottom by the exact same thing here. And in order to decide what that one thing is, just pick one term and match it up with the term it needs to go to, and that'll tell you what to do. Okay? So let's try this again. Let's go to the next term, or the next problem. This problem is really similar to the one right before this in the sense of everything was to the first power, so I'm only going to use my primary function, my primary identities, and I'm going from one fraction to one fraction. The difference here though is I have one term in the top going to two terms, and then two terms in the bottom going to one term. Okay? So when this happens, again, the exact same steps we're going to apply throughout anytime you have this scenario where it's going to go, you almost need to swap the terms around. Instead of going 1 to 2, I wish it was 1 to 1, but here are the steps on how to do it. Take your fraction that you're starting out with, and you're going to be multiplying again by a new thing. What's going to be in there is always the conjugate of your two terms. Well, the two terms are here in the denominator. It's secant y plus 1, and the conjugate then is secant y minus 1 over secant y minus 1. Okay? So again, when you have a fraction to a fraction, and you have one term matching to 2 and 2 matching to 1, just take what you're starting with and multiply by the conjugate of the two term one. Okay? And then from here, let's just simplify. So it says tangent of y times secant y minus 1 over, and let's go ahead and FOIL these out. So secant y times secant y is a secant squared y. Outside would be a minus secant y. Whoops. Insides would be a positive secant y. And last would be a minus 1. And by choosing the conjugate, you can see right here that negative secant y is going to cancel with a positive secant y, and that goes away. Okay, I'm choosing not to distribute the top here in just a second. You're going to see why. Over secant squared y minus 1. Okay, so right now I've still got some work to do, but this bottom right here is kind of looking familiar. I'm going, okay, what is secant squared y minus 1? Well, we have that identity. The identity says that tangent squared, we'll say y this time, plus 1 is secant squared. Well, if I move the 1 over, it's basically saying tangent squared y is secant squared y minus 1. There you go. I can replace all of secant squared y with tangent squared y. That's what I'm going to do. So the top still stays as tangent of y minus, or times secant of y minus 1. And the bottom, I can replace both of those terms with just tangent squared y. Okay? Out front here, I've got a tangent to the first. Down here, I've got two of them. So the one up top is going to cancel with one of those in the bottom. And I'm left with secant y. I really don't like to write that c in there, do I? But it's going to be secant of y minus 1 over tangent of y. And there's my answer.